Welcome, software engineers, to day 4 of CSC 222 Software Engineering. It's good to see you. As you can tell, I'm coming to you from your lab. Where are you guys? Wow, and it's warm here. I didn't dress up today because it's a little warm in Southern California today. All right, no, this is just a virtual background that Professor Tallman supplied to me, but I do know it's warm there, so I hope you are staying cool. Yeah, that's kind of important. Onward, shall we? For those of you that are wondering, we are going to be talking about assignment 0. If you take a look online at Blackboard, I gave you some feedback. If you have questions about that, and I've talked to a couple people, feel free to contact me about that. I do apologize. Monday and Wednesdays, I have 4 courses that I'm teaching on the MEC 1 campus, Concordia University, MEC 1. So if you send me an email message, I try not to get lost with those things, but I will ultimately get back to you and respond. Hang in there. We're going to take a look at what I was looking for in assignment 0, because conceptually, it's very difficult. It's a different mindset. We talked just a little bit last week about the difference between a data-driven app. That's what you're used to. And I know a number of us were trying to, I'm going to use a loop. No, that's the data-driven mindset. We're thinking in a different conceptual world here. We're looking at event-driven apps. So I'll talk about the difference. I'll show you the difference. I'm going to show you my assignment 0, if it runs in Windows. I'll show you the code, and even if I can't get to it, I've got it screen captured so you can see it. I don't want anybody to not understand this. I think the best way is for us, you, to struggle with that a little bit, think about it, and then we'll see a way to solve the problem. Before we get to looking at assignment 0, though, let's do some interesting software engineering stuff. You're going to get tired of hearing me say this, but it is important. Software engineering is defined as the management of the entire software development process. You may get tired of Dilbert too. Sometimes I put too many of these in here, so feel free to tell me when you get overloaded with this stuff. Boss, are you interested in becoming a manager? Dilbert, that would never work. Managers are supposed to hire people who are smarter than they are. That's easy for you. But how would I ever find anyone to hire? I don't understand. And that makes you a perfect manager. Well, that's Dilbert's perception isn't always there. But the point of this comic is to realize that management in this sense isn't dealing primarily with supervising other people. It's the management of my skills, my time, my ability, the product I'm working on through the process of software engineering. Management entails a lot. At some point in time in this class, I'm going to ask you on a quiz or an exam to define software engineering. I hope you'll start with this sentence, but don't end here. This isn't enough. As you read in the text last week and this week, management encompasses a lot of stuff. So start here, good beginning of the definition, don't end there. Another way to think about our subject, oops, did I miss something? Oh no, I was supposed to do that, wasn't I? Yeah. Quiz 1, I wanted you to do on Monday. Each week we'll have a quiz that primarily covers the material in the reading from the previous week. I will be talking about much of in the reading, so you've heard it a couple times, but just to ensure that you've read it. The quizzes are open book, open notes. I'd ask you to be closed neighbor and closed other online resources, but they're timed. And as you notice, when you start the quiz in Blackboard there, not only is there a time limit, but it doesn't allow you to pause. I'm sorry, not a video game. You can't pause, and there's no respawning here. If you leave, it closes it down. That's the way Blackboard quizzes are designed. Today, assignment 1 is due. That was the prototype. I gave you some thoughts on how to do that last time, and I was hoping that thinking about that prototype would give you some insights into the code. And again, we'll review that. Today, yeah, right. Last time I talked about the Christianity and computer science assignments. CNCS1 is due next time. Now, typically, the next logical day after one of our Wednesdays would be a Monday, but next Monday is Labor Day. We don't have classes on Labor Day. So next time is a week from today. We'll say more about that. They see it's easier to ask for forgiveness than permission. And I thought I was playing a VR game and I accidentally killed a guy from the marketing department. In my defense, VR games are very realistic, and he did look like an ogre. It's pretty morbid. We better move on. We've defined software engineering. Another way to think about it is to describe software engineering. I describe software engineering as professional problem solving. Computer science is problem solving. That's what we do. Hey, I need an app to add numbers, to do the running total pattern. But unlike a coder or a programmer, software engineers do things in a professional way. To the outsider, it looks like it's more work. Why aren't you just throwing code at it? But for those of us that do it, we realize that there's some other things that need to be accomplished before you throw code at it, like understanding the problem. Each week, I'm going to be sharing with you some aspects of professionalism. Monday, I said, here's my first one, being dedicated. Another word is committed, being all in. For those of us that are interested in doing something, let's leave school and academics out of this. You've got some other outside interest and you'd really like to be involved. Is it sports, whether that's intramural or intercollegiate? Is it some kind of activity, photography, racing? Whatever it might be, something that you're really interested in, you will be dedicated to that task. Do you want to be a very good musician? You're going to be dedicated to practice. You want to be a good ball player? You're going to be dedicated to practice. You want to create beautiful art, macrame, whatever it might be, that's something that interests you. And you really want to do it well, you're going to be dedicated. Professional software engineers are dedicated to their task. Southern California, maybe you don't follow basketball. Any basketball teams in Southern California? Sorry, just kidding. Don't do the hate stuff already. Well, yeah, I know the last 2 years there is some little guy who plays for the Denver Nuggets won the National Basketball Association Most Valuable Player Award. But in the previous 2 years is somebody local to me, Giannis. If I could pronounce Giannis's last name, I would tell you it's Greek. If you follow sports in general or basketball specifically, love the Bucks. Good man, Nate. Yeah. And the interesting thing is when you talk to Giannis's teammates, coaches, other players, etc., they'll tell you, man, is he dedicated. First one in the gym, last one out. First one on the floor, last one out. Practicing all the time, working. You're saying, well, he's at the pinnacle, he's at the top of his game. What? Well, no, you don't stay there, right? You got to keep working. Anybody remember a time when MVP awards weren't sponsored by automobiles or ketchup or things like that? The Kia MVP. Moral of the story: professionals are dedicated, they're committed to their task. In the CNCS assignments, I'm going to ask you to think about an aspect of professionalism in the context of one of the commandments. If you don't know about the commandments because you don't have a religious or Christian background, that's okay. I'm going to share them with you. If you know about the commandments, but you don't have a Lutheran or Catholic background, there's going to come a time when the numbering is going to be different. You're going to say, wait a minute, that's not the sixth commandment. I know the sixth commandment. That's okay. Because when you look at the biblical text, God does not say first, second, third. There actually looks like there are 12 imperative statements there. But historically, it's called the Decalogue, the 10 words. So it's okay. Sometimes people number them differently. And Lutherans look at the way that Martin Luther numbered them in his catechism. Regardless, here's the first commandment. You can read about it in the biblical book of Exodus, chapter 20, verse 3. First commandment: you shall have no other gods. Martin Luther wrote a book called a catechism. He wrote it in the 16th century. Lutherans and many other religious people still look at it. Language has been updated today. One of the things Luther did is he wanted to expound on it. If you're a theologian, it's easy to figure out what this means because you have lots of theology background. You know the Bible, you know the concepts. But for those of us that are not theologians, Martin Luther wanted to express this in some straightforward ways. So in his catechism, he tried to explain, and he's got a famous catchphrase: what does this mean? If you're a Lutheran, you've heard that before. Luther says, what does "you shall have no other gods" mean? We should fear, love, and trust in God above all things. Yep, that's dedication. So in the CNCS1 assignment, this is it. What I want you to do is answer this question big and bold. What is commitment? You don't have to give me a dictionary definition. Give me your own understanding. If you want to look up in the dictionary, that's fine. And this doesn't have to be long and involved. This is a sentence, maybe two. What's commitment? Now, let's relate it. Speculate, why do you think that first commandment is first in the list of commandments? If you don't know what the other ones are, you can go to Exodus chapter 20, Deuteronomy chapter 5. I've got a link in the assignment to the catechism. You can look there. Why do you suppose that the first commandment is first? And then I want you to think about, how does a computer science or information technology professional demonstrate commitment? How do we show dedication? Give me an example. By illustrate, I mean, give me an example. Don't draw a picture. Just give me an example. Just write something out. The CNCS assignments are short. You can answer them well in half a page. You don't have to write a lot. I just want you to think a lot and then express your thoughts. So CNCS1, and by the way, we'll have one of these assignments every week. Oh boy, oh boy. Last week, I shared with you, for a Christian, the 10 Commandments are a framework for our lives. They're an aspect of Christian ethical behavior. They're not the only thing that deals with Christian ethics, but they're a very visible thing, the law. It's a framework for how we live our lives, our relationship with God, our relationship with other people. In a similar way, that SDLC, Software Development Lifecycle, that we introduced last week, we're going to be talking about every week because it's the heart and core framework or process of software engineering. The SDLC is a framework for the job that we do as software engineers. So it's important, if it helps, to think about the commandments and how they relate to how I live my life. Similar thing with the SDLC. You're saying, hey, not everybody follows the commandments. You're right. I don't. What a horrible thing to admit. But do software engineers always do the right thing that the software development lifecycle says? Nope. No. Sorry. Sometimes the boss comes and says, get busy. You may have heard this. Studies show it takes 10,000 hours of practice to be great at anything. I would think a willingness to practice the same thing for 10,000 hours is a mental disorder. That makes me feel better about my mediocrity. You're welcome. You know, it is repetition. Think about programming. What we say, and I bet Professor Tallman says something similar, that the faculty here at the Mequon campus say this all the time. The first X hundred hours you're coding, you're going to feel like, I don't have a clue what I'm doing. I don't know why it worked. I don't know why it didn't work. But after you put in the time and after you put in the hours, at some point in time, something clicks. You might not even notice it. Things might just start working and you start yelling at other people. Yeah, being dedicated is about putting in the time. You know that. All right. Again, software development lifecycle. It seems to me funny. Why is it called SD and then LC? The LC is life cycle, but SDL, I guess, sounds funny, too much like LSD. So all software engineers, when they talk about the software development lifecycle, call it the SDLC. By definition, it's a way to manage the project by monitoring its progress from various stages from beginning to end, conception to death, start to finish, however you want to phrase it. It's the way to manage the project by monitoring its progress. How do we monitor progress? Things called milestones. We began talking about that last time. A requirements document, a rapid prototype. Those are very specific, visible, tangible markers of progress. Imagine it was this way. Imagine your boss came up to you and said, how are you doing on that project? You'd say, fine, good. Yep, everything's great. No information has been exchanged. Nobody knows where you are in the project. If, on the other hand, you say, I'm creating the planning document in the specifications phase, everybody knows where you are. They know you've completed 4 milestones, 3 in requirements and 1 in specs up until this point, and you're working on the 5th major one, or whatever it is. So we can actually spend some time looking at assignment 0 and looking at code and doing things. I'm going to ask you, the burden's going to be on you to investigate a couple things in the reading for this week. Last week, we uncovered the software crisis, and I mentioned what I call the unholy trinity. Late, over budget, full of bugs. We all know there are problems with software development. There are big, huge problems with software development. Later in this course, on the second unit of this course, so that's 4 weeks away or something, we're going to read an article by an eminent computer scientist. As a matter of fact, we're going to read 4 articles by this guy, Fred Brooks. Fred Brooks wrote an article called No Silver Bullet. You might know that in mythology, the only way to slay a werewolf is to use a silver bullet. Today, when people talk about a silver bullet, they're talking about a magic, quick solution to a problem. A silver bullet is a, if you will, magic solution. Now, it doesn't really have to be magic. We mean it's quick, it happens, it's painless, it's, you got this complex problem, just, those late night infomercials, just buy this thing and, the scar lines from your face surgery will disappear. No, they don't. Fred Brooks and other people who've investigated software engineering would say there's no magic solution to make it easy. Software engineering is hard. It's a difficult human process. I believe it's one of the most difficult human undertakings. You want some context? Historically, think about, I got this in the text, the Apollo mission to the moon and the programmers that dealt that and the stacks and reams of code. Wow. Software engineering is hard. Well, guess what? I'd like you to read through this week's chapter and make sure you understand, here are some of the reasons and what this means and how it relates to the fact that software engineering is hard. These are some attributes of software. And these are 4 reasons why software engineering is hard. But I want you to read about it. I want you to understand what each of these things mean. Little description in the notes today, probably not a lot. Read the text. So, if software engineering is hard and difficult and we end up with software that's crummy, how do you improve it? Well, here's one way. As you can see, we've thought carefully about ways of improving staff productivity in this company. How do we improve software engineering? Well, there's 2 different things to consider. First of all is, can we improve the process? What we do as we are creating software. That's what software engineering really focused on in the beginning. Software engineering was an art form, very undisciplined, unprofessional. Let's find a way to make it better, the process. You'll read about this acronym in the text, CMM, the Capability Maturity Model. This was one of the attempts, is one of the attempts to improve the process of software engineering. This was developed by something called the Software Engineering Institute at Carnegie Mellon University. Originally, 20 years ago, they were a quasi-governmental facility, really focused on improving military software. Today, they're sort of independent and focus on any kind of software production activity. Do I have a link? I do. You can investigate that. Don't you love TLAs? 3-letter acronyms. SEI, Software Engineering Institute. You don't have to remember that. CMU, Carnegie Mellon University in Pittsburgh, Pennsylvania. You don't have to remember that. CMM, yeah, Capability Maturity Model. And please read some more about that. Whew, I didn't know I was going to make it till a break. Whew. Did you know that Chuck Norris can't test for equality? He has no equal. Can't. So I'm just waiting for the riotous laughter to die down. All right, didn't like this one. How about this one? Boss, how good are you with PowerPoint? Me, I excel at it. Boss, was that an office pun? Me, Word. Oh, we don't say word anymore? We don't say word to Big Bird? Darn. Well, okay. Okay, I'm trying here. I know what you're thinking. Not very well. There's something else to improve. As a matter of fact, the first one that I showed you might have thought, well, that's a funny thing to improve, improving the process. Why not improve the product? I mean, that's what's wrong, right? The user gets this software late, costs too much, and it's full of bugs. Why not improve the product? Well, I'm sure you know that the thought is, hey, if we improve the process, we'll end up with a better product. Yet, there are different approaches to improving the product than improving the process itself. We hope that one would influence the other. But let's talk about ways to improve the product. This is going to be our first discussion of quality. Quality is a huge idea today in software. People are concerned about quality software. There are groups that work in companies and they're called quality assurance or SQA, software quality assurance. And one of their tasks is to determine, hey, is this quality software? How would they know? What is quality software? Here's a key idea. How do you measure it? A lot of people want to say, oh, quality software, that means it's good, it's fun, it looks pretty. You can't quantify any of those statements. If you want to improve something, you have to be able to measure it. So, how do you measure it? I'll leave that to you to think about a little bit, but you don't have to guess. Read about it in the book. In order to improve the product, we have to have a measure of its quality. So we can say, okay, my first attempt at, this, my 10th attempt, better. How do you know it's better? I measured it. I had a quantifiable way of doing that. Why don't some couples go to the gym together? Because some relationships just don't work out. If I didn't have these things in here, I'd go nuts. I mean, there's just, we got to pause every so often and see, don't work out. Yeah, I get it, mister. I can't show you some of your examples. Every time I would try to run them, Windows would go away. One of the more common approaches to solve assignment 0 was to just copy what I did in class. Now, what I said last week is this is a starting point, but this will not be assignment 0. So if you had 2 boxes, add, and then solution, and a number of people, I give you credit, tried to, maybe implement a clear, or some people threw a subtract in or something else around there, such that it wasn't exactly what we did in class. Good for you. I appreciate that extra effort. But this does not solve the problem. This does not meet the requirements. How do I add 3 numbers? How do I add 23 numbers? Now, a number of you thought about that and got stumped. And it's tough, I know. Some people had multiple input boxes. Other people were trying to run a loop, but okay. Other people had, in a pretty good solution, have a partial thing and then have another box over here to do it. Let's talk about a good way, or a way at least, to do assignment 0. I want us to get in the habit now of using meaningful comments. Comments are hard because amateurs write dumb comments. Comments are for other programmers or for you 2 months from now when you've forgotten what you've done. Here's how to tell a good comment from a bad comment. A good, meaningful comment explains why you're doing something, not what. If I have an assignment statement with a plus sign in it and my comment is add, well, yes, of course. If you're reading comments, you can read code. And you know full well that assignment statement is adding values. A better comment explains why I need to produce a running total. So as you're commenting your code in line, first of all, you don't have to comment every line. It's good practice to comment every module, whether that's a method or whether that's a block, however you think a module is. It's good unless it is painfully obvious. Okay, good. The other thing you need is an initial comment right up front in your code. Yes, this is my code. Thank you so much. Every module, and for us right now, we're just working with a single method, and every module needs a comment that identifies at least 3 things: the purpose, the author, and the date. The purpose, so you or somebody else can look at this and say, okay, this method does this, great. That's not what I'm interested in maintaining right now, or that's not what I need to duplicate right now. The author, so we know who to blame in the future. And date, yeah, it's pretty critical because there's all kinds of date management issues involved. So I didn't ding people for not doing this on assignment 0. Some people were doing this pretty well, but I usually left a comment like something like, you need meaningful comments. And now you know what I mean by meaningful comments. This is hard to do. Many of you were able to upload the 2 files that I need. Excellent, outstanding work. This is hard to do. It's not obvious what's happening here. I needed 2 things. First of all, I needed your code, your Visual C# source code. The problem is if you look in Windows and it shows the type, there's several things that say, well, you want the form 1, and if it's the first form, it's form 1, etc. Now, how could you tell? The answer is, if you will just open one of these up, if you just throw one of these into Notepad, WordPad, TextEdit, whatever it is, it will show you what's there. If it looks like what you did, then good. Oh, look, several more here. There's a lot of things that say source code. But in general, at least for now, they're single method. We want form1.cs. The form1 designer, this is code for the form. It is XML and some other kind of C stuff. Okay. Program is the caller. There's nothing in there. And so it goes. Okay. Be careful. I don't want project files or other things. So I wanted the source code. You'll find that under the subdirectory that Visual Studio creates. At that main level, creates a subdirectory. You'll find form1.cs. You see multiple source codes, just push those into a text editor like WordPad. If you see the code that you created, that's it. Now, the other one, uploading the executable file. Let's go through that again. But first of all, let me tell you why we're doing this. I had one person say, this is a dumb, well, okay, didn't phrase it that way. This is a dumb way of doing it. Why don't we do X or Y or Z? Yeah, right. There are many ways to deploy software. Something you likely, well, maybe you've done it before, but we don't think about this. I create the code, I'm done. How do I deploy it? How do I get it to the user? I'm assuming nobody has tried to upload an executable file to Blackboard before and see that it fails, and then have to do this funky thing of changing its file extension. This is just one of the myriad of activities that deal with management in the context of software engineering. So why? I just wanted you to have another tool under your belt. Part of deployment, we're working with Blackboard. This is how Blackboard demands it, really. Hopefully, I mentioned last week, Blackboard will not allow you to upload an executable, an EXE, because that's machine language code. And it knows if you don't know what you're doing and run it on your machine, it could do nefarious, that is, bad things, right? That's how you can infect your machine with malware. But what we're doing is we're fooling Blackboard, changing the file extension from, we're not changing anything other than its file extension to PGM. PGM doesn't mean anything. I said it means program. It's not a standard extension in Windows, so Windows won't care. You upload that, Blackboard says, oh, it's fine, not an executable, it's okay. Funny. Now, how do I find the executable file? Well, again, in that folder, you're going to find a couple different things. You'll find at the root here the SLN. The SLN file is just a bunch of pointers. This is the Visual Studio Solution file. All it does is it sets Studio up and it says, here's the form, here's the code, here's the project, here's this, that, and the other thing. It's just a bunch of pointers. You send that to somebody, it won't help. It doesn't help at all. So you need to push down into this next level, the subdirectory, open up the next subdirectory, and that's what I showed you before. Here is the source code, blah, blah, blah. Now, the executable is in a subdirectory called bin. It's an abbreviation for binary. And eons ago in the Unix world, all code was called binaries. Okay. So you find the bin subfolder within the name of your project subfolder and you open it up. Now, you may see more. I mean, there may be other things here, but then you look for another file called debug. You open up debug, and there you'll find several files, one of which will be the application. Now, this is a hideous thing. If you don't have file extensions turned on, and by default, Windows doesn't show you file extensions. So you'd see win-add-num sprint1, but this second file would look like it's an exe. But notice it's .exe.config. It's really a config file. You're saying, how do I ensure that I've got, well, I showed you this last time. Go to the view menu of the window and turn on file name extension so you can actually see it. If you can't see it, then just note it's the type application. It's an application. Now, that's the one, copy that somewhere. Don't change its name here. Copy it somewhere, maybe to your desktop. Rename it as a .pgm, upload it. Guess what I did? Well, I've tried to automate this, right? I have Blackboard download everything as a zip file. And you uploaded a zip within a zip, it broke it, but that's okay. It's not your fault. And then it unpackaged things, and it renamed things, and away I went. Good. We haven't seen assignment 1 yet. Does that come next? It does. But let me pause for a minute. Do you have any questions about just the logistics of deployment? Getting my source code. We're going to do this again, by the way. If you're thinking, oh, I didn't do it, I don't care. We're going to do it again a couple of times. Make sure we can all do this. I got to adjust something here. I'm going to stop the video for a second. Oh, look at that handsome guy. I'm still here, though. Do you have any questions? You can either put it in chat or feel free to unmute and say question. Or you can, yeah, question.
So for the rolling sum, can we have it where we're just inputting one number at a time, but it's consistently being added to a rolling sum?
Okay. Yes. Now, you're ahead of me. We're going to talk about that. Absolutely. Okay. Yep, that is exactly right. Any questions about deployment? Where, hopefully this helps again, seeing this. But what will really help, of course, is when you actually do it. There's no substitute to 10,000 hours of practice. Any other questions? Okay. Let's then talk about the code itself. Now, this is not the be-all, end-all. As a matter of fact, there's a lot of things that I don't like about this. Form 1, no instructions, etc. But here's a screenshot of a way to do it. Now you're saying, wait a minute. Number total. Well, we're doing this in an event-driven way. Let's jump into Blackboard a minute. And now that you've struggled with it, maybe some of the help that I had there would make more sense. Okay. Visual Studio for software engineering, that's just getting it set up in your environment. Running total idea. This is a very common problem in computer science, happens every place. In computer science, there are a number of common problems, and to solve those, computer scientists have come up with what they call design patterns. This problem it happens so often that there is a known way of solving it. Running total idea. Requirements answer the why question, specs the what question, design the how. Sorry, PDL is program description language. Some people refer to that as pseudocode. I should check with Professor Tallman and see if there's a term that he uses. But when you're designing code, it's much easier to use PDL, English-like words, as opposed to all the syntax of C# or whatever it is. So again, if you're adding two values, that makes sense. We know how to do that. But what if I need to add any number of things? Rather than adding two discrete values, you approach the problem by adding the current input to the previous running total. If it helps, think about what you do on a calculator. On a cheap calculator, right? I mean, there's just one line of display. So you type in one thing plus another thing plus another thing plus, and it keeps adding it to the running total. Okay. Here's the PDL pseudocode. Now, instantiation means to actually do it, create the code. Data-driven. This is not how we are doing things. But if this were a data-driven, like a console app, like you run it, all right, then we'd use a loop, right? We would use 0 as our flag. If the user types in a 0, that means to end. That's our flag value. So while the input is not 0, then we would continue. We would initialize our running total to 0. You notice I have this as an int, right? You know that's not going to work, but okay. I would get it off the console. I'd throw it in. I'd keep adding it to the running total, whatever the num was, the input was. And when I was all done, I'd output the running total. That's not us. We're doing event driven. Here's my hint. You don't need a loop. Why not? The user will command the process. Every time the user clicks add, the program will do something. You don't need to make the program loop. It's event driven. The user continue to press the add button till there are no more values to sum. Let's switch. By the way, remind me, I sometimes panic after talked a long time. Did I switch over to Blackboard? Looks like I did. You know what? I'm going to do something scary. Here's my code. No, it's Doc Locke's code. Here's some code somebody wrote. Let's come back and take that apart. But let me try to run this implementation for you so you can get a sense for what it's doing. And then we'll come back and parse that code. All right. So let's take a look at, where'd it go? Oh, here's Windows. Here's my assignment 0. Oops, I apologize. I can't. 370 is the number at Mequon, which I'm not teaching right now, but every time I think software, if you see 370 on anything, just realize the guy's old and doesn't remember stuff. This is CSC 222. At least I think it is. All right, you ready? Here it is. I'm going to wait a second to see if parallels drops dead. Did not. Okay. So let's type in a value. Now, another weird thing is, well, how do I begin? You got to add 2 numbers. Well, that's the conceptual hard part. I'm going to add it. What's the current running total? You initialize the running total to 0. The first time it's adding 0 plus the input. The next time it's the running total plus the input. So I'm sure you've come across this in other classes. You know, first case is different. End case is different. Hey, will it accept fractional values? Very good. So now notice, if I don't type in anything, it's not doing anything. It's only going to do something when I give it a command, an event. And that event, the only event on this form, is the add button. There it goes. Don't forget about, it's really important to have error trapping. You know, I meant to type 2, but my finger didn't go up far enough and I typed a W instead. You want to be able to trap that. Don't have the system append or drop dead to the OS. Invalid data input. Please enter numbers. And the user looks at that and says, "Oh!" All right. So now I can type a number and away I go. Seeing this isn't easy. It's a very different way of thinking about things. But this is a lot of the world of computer science today, right? I mean, any app you use on your phone is event-driven. Most desktop apps are event-driven. It's a different mindset. Different mindset, we're going to have to develop that. The only way you can do it is to do it. All right, I'm going to close down. By the way, don't forget, when you are in Visual Studio and you say start without debugging and you run, if you find a problem, don't immediately switch back to the code and change the code. Shut down the instance of that app. If you don't, your changes won't stick. There'll be funny things happening there. Oh, life is bad. Okay. What's this? I had another instance of that. Okay, fine. Let's look at the code. After we spend a moment with the code, then if you've got questions on either the app that you saw or this code, let's have it. Let's understand this. Let's look at it in a big, broad sense. Okay? The only event on my form is this method here, button one click. Good name, my button. You're saying, hey, I called my button add. No, that was the label on your button. To the program, your button is button one. Now, I agree, that's not a good name. And you can change that in the button properties. We'll see that as we move along. Okay, so here's my method, button one click. So when the user clicks the button, what's going to happen? Well, first of all, here's our try catch construct. So we know if anything other than a double is input, then we will throw up a message box that says invalidate on input, please enter numbers. Good. All right. Now, what do we do? Well, here I'm grabbing we saw this before, right? We're taking something out of that text box, that input text box. We're grabbing what's there, the text in text box one, using the toDouble method to convert it into an actual double value. The variable input here is cast as a double, so it's going to work fine. Now, really, I think that these comments here are a little superfluous. I don't think a professional programmer, you could look at the code and see what's happening. They're there just to help us hang on to the idea. Good. All right. Now what do I do? Well, now what I do is I say, okay, take the input that I just had, add it to my current running total. Now, yes, now you're saying, hey, is there a simpler way? Couldn't I just reuse that variable running total? Yeah, you could. Lots of ways to do this, but I just want to make it very explicit what's happening. So take the input that I just got from the user, add it to the current running total, call it output. Convert that to a string, throw output into that particular text box. And then I'm going to update the value in running total. Running total used to be the previous time. Now it is output, the new sum. But you're saying, what about the first time? What's right? Well, yeah, right. You need to initialize it. Here's that special case. The very first time running total is 0. We didn't say anything at all. Well, you can't leave it blank, right? You know the problems with not initializing variables. So I set my variable running total to 0. Good. By the way, do that outside of the scope of the event. If I, for example, if I set running total to 0 anywhere within this method, every time you click it, reset to 0 and you'd never get anywhere. So notice I have it in the scope of the entire form class, right? That makes sense. I want it 0 here, but I don't want it to be 0 as I'm doing things in here. I want it to be whatever the output calculated is. Here's my initial comment. App to add numbers. Each event adds the contents of the input to the running total. Put your name, the date, and anything else that's appropriate and important there. Here is one way to do it. Are there better ways? You bet. But this will work. Oops, come on. The one thing you can never tell just by looking at the code is what's the form look like. And what is text box 1? And what is text box 2, etc. Well, and what is button one? In a simplistic form like this, you can probably deduce that. In a more complex thing, in addition to seeing the code, we'd actually need to see the form designer later. Any questions? I'm sorry we're not done. I'm going to talk about a couple other things, but any questions that you have right now regarding a way to do assignment 0? Is this really what your lab looks like, by the way? There are things stacked up on other things. It's okay. It's all right. Yeah. Does it look like this? Good. Do you have air conditioning in your lab? Funny story. When I first arrived on the campus at Concordia University, Wisconsin in Mequon, very good. Glad to hear it. We had this computer lab, we'll call it, but there was no high vac, no heat, no air. And I kept asking for it, and they said, "Oh, come on." One day, the president of the university needed me to show him something computerized. So he came down to the lab. We were doing something. Suddenly, one of the machines stopped, just stopped. He said, "Why did it do that?" I said, "It's too hot in here." Got air conditioning that week. Now, did it stop because it was too hot? I don't know, but I'm glad I got it. Okay, any questions about that? All right. Folks, you're going to do this again. Assignment 4, we're going to skip 2 and 3. We got to make sure that we're all on the same page here with this code. So we're going to come back to 3. We're just going to skip 2. We'll come back to 3. But assignment 4 is the first sprint, the first real addition of add numbers. Talk about it a little bit. I would encourage you, if you're not following this, just copy it down. Now, I don't want to give you the code because there's some benefit to actually physically typing it in yourself. And just get this to work. That's not time wasted, not at all. Again, I'm going to ask you to take a look in the text at some of these things, but let me give you a high-level overview of the requirements phase. Last time we surveyed, we at least mentioned all 6 phases of the software development lifecycle. Let's talk about the requirements phase. The requirements phase answers this question. You know you've done the requirements phase when you can answer this question and the next one. Why is there a problem? Now you'd think, the legitimate question is, what is the problem? The first question is, why is there a problem? If you understand the why, you'll understand the what. Folks can get the what, and if they don't understand the why, they usually end up creating the wrong thing. This is important. Requirements ask the question, why is there a problem? Another way of thinking about that, so why do I need a computer to solve this problem? What's needed to solve it? An app? Sure. Why is there a problem? What is the problem? That's the heart of requirements. Now, computer science-wise, you know you are doing the requirements if you can then, after the requirements, talk about the outputs, the necessary and required outputs of your app for the user. For our add nums program, the only output we know about right now is a running total. But the requirements, computer science-wise, focus on the outputs. Again, it answers the why questions. The other thing that happens in the requirements phase is a prototype, like what you did for assignment 1. Prototype is just a communication tool. The user looks at it, says, yeah, good. Or no, I don't think so. It's a way to figure out, do you really understand the problem? Yeah. Zeb's a little bit overweight. Martha sent him to the doctor. He had to go on a diet. The doctor told him, okay, I haven't had success with too many things. Here's a new diet I want you to try. This is how you do it. You eat regularly for 2 days, and then you skip a day. You eat regularly for the next 2 days after that, and then you skip a day. And you keep this up. And after a month, you come back here. Well, after a month, Zeb came back. He had lost like 70 pounds. And the doctor says, that's amazing. But Zeb said, oh, doc, I thought I would die that 3rd day. And the doctor says, from not eating? Zeb says, not eating? No, from skipping all day. Skip a day? They're laughing out there. All right, let's take a look at this. We're going to be doing this project in various incarnations through half of the semester. So please ensure that you understand what we've done now and what I've showed you today. You need it for the next steps, okay? Let me tell you the requirements of assignment 0, which the next step for you guys is assignment 4. Here are the requirements. Why is there a problem? Our users work in a large machine shop, and there are a number of industrial PCs. This is an industrial PC. There's a computer, and mostly they're Windows-based, and they control a piece of machinery. In this machine shop, there's a lot of scrap metal left over from various processes of forming and cutting and bending. There's a lot of scrap metal. The owner used to throw the scrap metal away, but said, well, that's dumb. Isn't there something we can do with it? They repurposed one of their machines to take the scrap metal and to punch out shims. If you know what a shim is, don't worry about it. It's just typically a little piece of metal or wood that's used to build something up, but they're little. And the owner thought, this would be great. I can take all my scrap, punch it out, and then I can sell this. So rather than disposing of the scrap material, it's going to be repurposed. It's going to be reused. So what's the problem? That's why there's a problem. What's the problem? As a byproduct of the manufacturing process, there are a number of leftovers. To avoid waste, the leftovers are packaged into bundles. The machine gives an accurate weight of each shim. The user needs to add up the weight of the shims in the bundle and put that as a label on the bundle. What's needed to solve the problem? A Windows desktop app. Why? Because the IPCs run Windows. Why can't the user just pull out a calculator? The user is busy doing other things. The user has her hands on the IPC to control the machine, so she's familiar with the 10 key. She can just quickly switch to the app that we're going to make, punch in the value of the weight of the shim, add it to the running total, and then move back. Good? Good. All right. Folks, we're not going to do this yet. You'll see something online at Blackboard that talks about team roles. In the second half of the semester, we'll be working as teams to solve a problem, but I don't feel good moving on until we're all understanding assignment 0, etc. When we talk about teams, we'll talk about ways that teams are put together, etc. Now, if you take a look on Blackboard, you'll see dead links to 3 assignments after day 4. Assignment 2, we are not going to do. Assignment 3, we're not going to do now. We'll do later. But assignment 4, we will do. It's the running total program or app, what I call add nums. And I'm going to call this sprint 1. We'll talk more about sprints. Sprints are part of one type of software engineering called Scrum. We'll say more about what that means, etc. But think of a sprint as a small working subset of a much bigger problem. The problem that we need to solve is much bigger than I've shared with you. I'm not going to share with you the other parts of it right now. We'll just focus on getting a couple other things. So you'll read about this as soon as assignment 4 gets released in a little bit. Another term that's used for the very first incarnation of a product is sometimes proof of concept, POC. Is it possible to do the central idea? Is it possible at all to create an app that does a running total before we think about anything else? Well, the answer is yes. And I want you to do that. Yeah, we're not doing that today. All right. So I know you can't see it right this second, but soon when you go to Blackboard, it takes me too long to rearrange things. I'm going to leave assignment 2. They'll just go to dead links that they do right now. But assignment 4 will be up, and that is due a week from today. You'll see it there. Assignment 0, you've done. Assignment 1, you've done. C and CS1 due a week from today. Folks, let me commend you. For those of you that were able to submit something, I wasn't trying to penalize you greatly. You're saying, well, I only got X out of 10. There's only 10 points. Those points will be easily made up if you didn't do as well as you hoped. Don't sweat or panic right now. What I do want you to do right now is to work hard and think about the problem and create a really good implementation for assignment 4. If you have questions, concerns, send me a message. I do check my CUI email, but only once a day. If it's urgent, send it to me, locklear@cuw.edu. And unless it's a day when I'm teaching 4 other classes, I'll try to respond a little more quickly. Right. And you know, it's okay to interact with your classmates too. I don't want you to copy. You're not going to learn anything that way. But bouncing ideas off, and especially seeing the approach that somebody else took, I think is helpful. There are many modern software engineering frameworks, SDLCs, that deal with the concept of pair programming, where 2 or more software engineers just work on the exact same problem, bouncing ideas off and around. I'm going to stop the recording in just a moment after I bid you adieu. I'll hang out here for a few minutes if anybody has a question or concern. Otherwise, please reach out and contact me. So folks, first of all, let me say thank you for your hard work so far. If you haven't done any hard work, then I rescind that. If you didn't submit assignment 0, get busy. Let's do it. All right. Thank you for your hard work. Thank you for being part of the community of scholars there at Irvine. I appreciate the effort that you're putting into it. And with that, let me give you the good news. Don't come Monday. I asked Professor Tallman and President Thomas if we could, and they said, sure, take Monday off. Monday's the Labor Day holiday. But don't get too lax. Take that day off, but then do other things on Tuesday and before it. Have a nice day. Have a great day off on Monday. I will see you a week from today.